In this video, I want to make just a few comments about setting that positive direction. So anytime we're working with our vectors, we have to indicate the coordinate system that we're using. And primarily the important reason we're doing that is so we can give our vector quantities a direction, right? In the first video, we talked about free fall motion, and I diagrammed a setup where we were like throwing something up into the air. So here I'm going to do a situation where we're just dropping something. And so our motion is going to go from the top. So we're going to start here. And so we'll say that we're starting at rest. We're just going to release something. And so if I think about the motion, if it's just a free fall, then it's going to accelerate downward. Right? And we'll go ahead and just say this is the ground at the bottom. So to clarify, so this is going to be my start up here. And this would be our end. Okay, so it's still free fall motion. I don't have any other forces. It's just moving through the air, and we're neglecting air resistance. So this is our free fall motion. So if this is my interval, it's constant acceleration. So this is a y1. This is a vy1. I'm going to have some y2, a vy2. And acceleration in a time, right? Always have these same six variables here. So I'm going to diagram this. Actually, I'm going to just see if I can do this while I'm making the video. I'm going to see if I can copy and paste this because I want to do it twice. So I'm going to paste. See if I can get this all the way up here. So what I want to do is have this same situation. And I'm just going to talk through if we pick our coordinate system differently, how that affects our defined variables, right? So I'm going to scoot this one over just a little bit here as well. Okay, and put a divider in between them. Okay, so on the left-hand side, so let's do this one first. For this one, I'm going to just set, a lot of times if we're working for things, we like to just say that the up direction is positive. So I'm going to say y is positive as I'm going upward. So if we say y is positive going up, in this case, our motion is going down, right? So if y is positive going up, that means my velocities are negative. And in this case, we said that our initial velocity was 0. But if I think about that velocity at the bottom, I'm going to just make a note here because I'm not plugging in values, but I'm going to make a note that velocity at the bottom needs to be negative, right? Another thing I want to mention when we think about the velocity at the bottom, or a situation where something is about to hit the ground, I want to clarify that we're always thinking about that velocity right before it hits the ground. So if this is the ground here, and I drop something and the problem statement asks us for that final velocity, it's asking us for the velocity right before it impacts the ground. And so the final velocity is not 0. I mean, ultimately, if it hits the ground, it's going to go to 0. But we're thinking about this constant acceleration interval. And so as soon as the object is going to make contact with the ground, the acceleration changes, right? So it's no longer in free fall. So it's really important that when we're thinking about impact velocity, sometimes I'll use that phrase, or velocity at the bottom right before it hits the ground, that is not going to be 0. We're talking about right before it contacts the ground. So this velocity with our coordinate system here going positive going up means that velocity would be negative. In this case, my acceleration, right, our free fall acceleration is always directed down. So if I write in my acceleration here, this is going to be negative g. Magnitude is always g. That direction is indicated by whatever we set that coordinate system to be. So if I have my y positive going up, and I have free fall motion of something going down, velocity is negative and my acceleration is negative. Okay, so let's take the same scenario, but now I'm going to say my y is positive going down. And if this was the problem I'm working with, I probably would set this up so that my y is positive going down. I tend to like to make my velocities positive or keep my velocities positive if I can. So since my object is moving down, I like to set my coordinate system in the same direction that I'm moving. So if y is positive going down, then my acceleration is still this way. So my acceleration here would be a positive g. My velocity at the bottom would now be a positive velocity. We can do the same situation where my initial velocity is 0, so it's not going to be positive or negative. But this is just showing that case where if I change the direction of that coordinate system, I do need to make those changes in my my designation of those variables, right? Especially the ones that are vectors. So the other thing I want to highlight in here is the positions. And so if my y is positive going down, like I have over here on the right, then I will probably want to set that y position as 0 at the top, right? So I can say that that is my y position. And then down here, this might be some height, right? So that change in position there. So if my y is positive going down, I can still set that initial y position as 0. That's consistent with how we tend to set a lot of these things up like that. If we look at the other case where if we have our y positive going up, so I'm going back to that left-hand side, if I say that this y initial is 0, then my y2 needs to be a negative h, right? So we want to be careful with using those coordinate systems. If this is my 0, right? So if this is my 0 point, then positive numbers go this way and negative numbers go this way. So we just need to be careful with that. A lot of times if I would have a situation like this, I would probably say that this is my 0, right? Say that y is 0 down here. And then that means that my starting point then is just no longer 0. It's going to be some distance h above that 0 point. So just wanted to make a quick video highlighting kind of the importance of that coordinate system. So sometimes we just throw the coordinate system in there and don't really think about it. But hopefully this helps illustrate some of the things we do need to be thinking about if we're when we're setting that coordinate system and what the consequences of that coordinate system are. So we need to make sure that all of our defined variables are consistent with that coordinate system that we identify.